In this video, you'll be explaining lesson 18.1, which will focus on galvanic cells. Galvanic cells, which are also known as voltaic cells, use the electron transfer in redox reactions to turn chemical energy into electrical energy. This reaction is spontaneous, and the most common form of galvanic cells will include two rods called electrodes, which have different electronegativity and will be partially submerged in an acid. They will also contain a salt bridge, which will aid in the transfer of electrons. As you may recall from last lesson, redox reactions can be separated into two parts, the reduction half and the oxidation half. As you may also recall, the oxidation reaction involves a loss of electrons. In galvanic cells, the side which loses electrons is called the anode. And the side that gains electrons, which can also be referred to as undergoing reduction, is called the cathode. So one thing to keep in mind is that ions are more easily soluble in the acid medium here. So once this neutral anode loses its electrons, it becomes positively charged ions, meaning it's going to dissolve into the acid and lose mass, while this, which was originally positive, will gain electrons, which will therefore become neutral and stick to uh, the electrode, meaning that the cathode side will gain mass. As you may have noticed, the wire has arrows with electrons pointing to the cathode side. This shows that the electrons will always be moving from the anode to the cathode. One thing to keep in mind is that the anode doesn't always have to be on the left side. Sometimes it can be on the right side. It just depends on the illustration. The final component of the galvanic cell is the salt bridge. The main function of the salt bridge is to balance out the charges on each side and keep the reaction going. You may have noticed that the negative half of the salt will always be going to the anode, and the positive half of the salt will always be going to the cathode. Okay, just to recap everything that's been stated earlier. Oxidation occurs at the anode, reduction occurs at the cathode, electrons flow spontaneously from the anode to the cathode. The anode is the negative terminal and the cathode is the positive terminal. Anodes gain mass while cathodes lose mass. In some rare cases, a non-solid electrode can be used, such as here where hydrogen gas is used, and on the other side, dissolved iron is used. In these cases, there's usually going to be a platinum or gold, in this case it's platinum, substitute, um, where here it's used mainly to gather electrons and to transfer them through the wire onto the other side of the reaction. Uh, these metals are specifically used due to their inert nature, which means they do not react and interfere with the redox reaction. Since galvanic cells contain many things, it can be hard to quickly describe them on paper. So scientists created galvanic cell diagrams to simplify how cells are illustrated. They're usually written as follows. There will be the anode electrode, so in this case it's going to be zinc, followed by a vertical line, and then the ions in the solution, which is going to be zinc 2 plus, followed by two vertical lines to represent the wire, and then the ion in the cathode part, which is going to be Cu2 plus, followed by a vertical line, and then the electrode, which is Cu. In the rare case mentioned earlier where PT is used, what we do is we write PT, then a vertical line, followed by the same steps. So the anode, vertical line, the ion, which is in this case H plus, followed by two vertical lines. And here, since both of them are aqueous, there is a rule that states after writing the first part, which is going to be Fe2 plus, instead of writing a vertical line, since they are both in the same medium, which is aqueous, we add only a comma. followed by the electrode, and then vertical line PT, since there's also a PT electrode on this side.